Namaste everyone. On behalf of Chanakya University and School of Engineering, I warmly welcome all the students and parents joining us today. Thank you for taking time to be part of this special interaction. Artificial intelligence is transforming our world at great pace. But here's the critical question. Who is building energy systems, electronics, and intelligent machines that makes AI possible? That's exactly what we are going to explore today. It's my pleasure to introduce our distinguished panel, Dr. Shobhana Padmanabhan, Director, School of Engineering. Welcome, ma'am.
Thank you.
Srihari HS, Program Coordinator, Electrical Sciences. Welcome, sir. Dr. Kingshuk Chatterjee, Assistant Professor, School of Engineering. Welcome, sir. Thank you all for joining us today. To begin today's discussion, I invite Dr. Shobhana Padmanabhan to share her thoughts on vision of School of Engineering.
At School of Engineering, our vision is to create cost-effective engineering solutions to India-specific requirements. In particular, this year we are taking up Viksit Gram to contribute to Viksit Bharat by 2047. Right? There are over 6 lakh villages in India with over 94 crore people living in those villages. Almost 16 to 20% of those village youths in the villages migrate to cities for better education, better standard of living. So instead, if we can create a national platform and contribute to the repository of problems faced by them and then take up problems that we can solve at the School of Engineering, we would be greatly contributing to the nation, right? So that is one thing. The other thing, we also collaborate with the industry and take up industry-defined research problems and projects. Okay, how we do it in the domain of electrical sciences, I'm going to leave it to the other two professors to talk about.
Thank you very much, ma'am. That beautifully sets the context for today's discussion. Dr. Kingshuk, let's first address the elephant in the room. How do you think AI is changing over the next decade?
Yeah, so this is the big question everyone has in their mind, I think, that how the job market, how the technologies, everything is going to change with AI. So I think we had parallels of AI throughout the history of technology. Firstly, if we look at steam engines and in the recent history, computers or internets, everything came in and they took away some jobs, they created some jobs. But what to look at is the nature of the job changed with each technology. Right. So we have to understand how the job market or what type of skills will evolve when AI takes over, which is happening at the moment. So if you think that AI is more of there are two aspects of AI, I will say. One is the AI technology where a handful of high quality AI engineers are going to develop the technology. And apart from that, how we integrate AI into other technologies. So I think though the craze of students taking CS&AI is very high, I think very few will be actually working on the technology. So what we need is more of, so AI will already replace most of the automated jobs, which can be easily done in front of a computer or in fact in front of any machines. Right. So the engineers will be demanded to do more real world problem solving and they will be needing more of the core engineering knowledges. So at the very outset, what is the general consensus among most people in this area is that AI expertise along with core domain knowledge is what is going to be standing out. So for example, whatever technology you're using, whatever technology you're working on, that technology will, if you're not AI skilled in AI, you will lag behind, right? But so for example, if someone is not using computer nowadays and a person who is using computer, you can see the performance difference in both the cases. So integrating AI in any technology will be very important. So they will be developing the new technologies, the new algorithms. But many people will be using those algorithms in their own sectors. So that is where I think the AI technology will evolve our technological advancements, evolve the nature of the job, and also demand more from this new bunch of students who are going to be taken in the job sector. So core domain knowledge along with the awareness or skill of AI technologies is where I think, and most people in the technology in the engineering services, they think is what industry is looking for.
So you say winners will combine core domain experts with AI. So that raises to a new question. Do you think still electrical engineering is still relevant in AI era?
Yeah, very much. I think electrical engineering is one of the major sectors that is going to push the AI, that is going to make AI a sustainable technology, I will say. Because if you look at the core of AI infrastructure, two things stand out. One is water, one is energy. Now, interestingly, water is still recyclable. Energy is not, right? So, water is of course a big issue, but the bigger issue is the power demand of these data centers. And as more and more people are using AI, these data centers are coming up in many parts of India. And so the power demand is increasing. The type of power quality these data centers need is increasing. So the entire ecosystem or the infrastructure for power transmission is having a massive change. It's a big challenge in the power industry, first of all. Then comes the energy source. So we all know that coal, oil, these things are slowly getting depleted, and by the end of this century, it is going to be almost gone. So renewable energy is one big area which need to happen to sustain not only AI, any kind of advancement in our technology. So again, as long as we do not invent, let's say, teleportation, we have to go for physical mobility. And as you saw in the recent geopolitics, oil is a very critical thing. And that's why India is pushing towards electric vehicles. And if you see, Bangalore is still a bit developed in kind of EV, in terms of EV infrastructure, but the rest of India is not at all, I will tell you. So there is huge scope of work and huge need of electrical engineering in mobility, in energy storage, in renewable energy sectors, in preparing the power sector to deliver power for AI infrastructure. So this one aspect is well established, that to have AI we need to have a good energy infrastructure. Also, AI is more of a cyber system, but to get the impact in the physical world we need to build cyber physical systems, right? So cyber physical system means we need to have control system, we need to have robotics. So how do you see AI impacting the world other than coming out from the computer? When does AI come out from the computer? You need cyber physical systems, and that is another area which is completely dominated by electrical engineering. You need control systems for that. You need to build autonomous vehicles, autonomous industries. In China we already have industries which are running without human. In India we need to have that. So we need engineers who are trained in AI as well as they have the domain expertise in electrical engineering. So I think these two are the major areas. And if you see the World Economic Forum report on the future of jobs published in 2025, the top 3 technologies which they forecasted are going to impact most in the job sector are AI, number 1, number 2 energy, number 3 automation. Yeah, automation. So all these 3, at least the next 2 after AI, are part of electrical engineering. So that's how you see that electrical engineering is not only relevant, but is actually a game changer in the present or the future era, the AI era.
So what Dr. Kinshuk is trying to tell is AI is the brain and electrical engineering is the backbone.
Absolutely.
So that is the essence of his take.
Dr. Kingshuk, what are some of the most exciting technology areas that today's electrical engineering students can contribute to over the next decade?
Yeah, there are lots of exciting areas, I will say. As I mentioned, the 3 main focus areas where electrical engineering is finding a lag of supply or more demand, both are happening. Firstly, it's the energy sector. So renewable energy, the industries are coming up, but we don't have enough supply of engineers. Okay, then the area of smart grid, where even integration of computation, integration of AI, and also understanding the microgrid, because renewable energy has come in. So microgrid engineering, smart grid, cyber security in power systems. Then you come to mobility, it's a huge world. You have to understand the machine parts, motor parts. Then you have to understand there is enough supply, enough demand for BMS technology, battery management system, and energy storage systems. And more we are going to integrate AI in the BMS technology, battery management system technology. So we need engineers who know the battery system, who know how an electric vehicle works, and who also are competent with AI and coding. So these hybrid roles are evolving nowadays. It was not so in the last 10 years, but now the engineering sector is mostly looking to hybrid engineers. So then there is the world of robotics and automation. Even electric vehicles are going to be autonomous. So that is part of a automation system. Though autonomous and automation are two different words, but they're very interrelated. So once the EV becomes autonomous, we need some control engineers, robotics engineers in EV technology. When the manufacturing industry is becoming autonomous, automation is happening there. So again, we need electrical engineers there. So energy sector, mobility sector, automation sector, these areas are going to be demanding many electrical engineers in the next decade. The demand is only going to rise, and that's why you see that combining electrical engineering with computer science is so important.
Professor Shriyari, how can undergraduate students prepare themselves for this emerging opportunities while they are still in the college?
Thank you, Satya, for that wonderful question. I think Dr. Kinshuk has beautifully summarized the importance of electrical engineering domain expertise in this AI era. Now, to answer your question, I think students should start building projects early in their engineering career. That's the first thing that I advise all students. Second, they should start developing practical engineering skills rather than solely concentrating on theoretical concepts. They should learn in the classroom the theory and apply them practically in lab and in their projects. Third, they should work on interdisciplinary and industry relevant program statements. They should talk to people from industry and also talk to different streams of engineering, other students in different engineering branches. And also at Chanakya, we have 6 different schools that they can put all these skills in their different departments. And finally, all this will help them to build a strong portfolio when they go to industry and start working. So I think these things will help a student to build a strong domain expertise and also a strong resume and portfolio when they are ready for industry oriented work. I think that is the main important.
Dr. Kinshuk, how does the EECS program at Chanakya University prepare students for this rapidly evolving industries?
Yeah, so that's a very important question, I think. So the core philosophy behind combining EECS, EE and computer science is what I have already established. We need people understanding the physical systems as well, competent with computational skills, both computer science as well as AI, because we will need computer networks, we will need quantum computing to integrate with electrical systems. Cyber security is a big area. As quantum computing develops, cyber security is going to change, and we need engineers who understand the power system, power electronics, also the quantum computing areas. So that's why the basic idea of combining these two, electricals and computer science, is established as of now. But how prepared we are? So if you look, most foreign universities, top foreign universities has combined electrical engineering and computer science from the beginning. So they don't have a computer science engineering as a department, they have electrical engineering and computer science, because computer science has evolved from electrical and electronics. So historically it is a continuation of electrical engineering. Now as industry is demanding more hybrid engineers, we have to prepare ourselves. So this culmination of these two streams, a hardware as well as a software, has to happen sometimes, and we have chosen it to happen at Chanakya University. So we want to make those students future ready first of all based on these demands, but more importantly we have potent mentors for them. Most of our faculty members are from IITs and also from foreign universities. So they come from a research ecosystem, right, and they continue their research work and they involve the BTech students into their research work. So we have good collaborations with industries, EV industry, battery management system and battery manufacturing industries, even automation industries. We have some talks. We have some very concrete talks in that level, that some projects we have already been working on and projects are going to come. So students get the chance to work actively in those projects. They can do internships in those industries, and that will pave the way for them to be included in those companies, to be hired in those companies. So it's a very smooth process in that sense, that you work with the faculty, you get in touch with the industries which the faculty is working on, and through that you get to that industries, you get to understand the industry ecosystem, and your chance of hiring increases, right. So project works will be more industry based than some very theoretical or obsolete areas, because the projects are coming from industries. So the students are always, the students who are serious and working on those projects, they are very much prepared to be adopted by the industry. And our curriculum, one of the main areas where we stressed were providing the electives. So after the end of second year, the students can choose two tracks of electives. So one track is specialized on energy systems, another is on automation and robotics. We named it control and automation. So the energy track, if they choose, they have the possibility to work in renewable energy systems, smart grids, electric vehicles, batteries, energy storage, all this, along with the computer science background. So they will learn computer networks, they will learn cyber security, all the things that are needed for them to excel in their area as a modern engineer, modern hybrid engineer. Same for autonomous system, automation, control and automation. They will be working in robotics, industrial automation, PLC and SCADA. So all these things again need both computer science as well as electrical engineering background. So these two pathways we can push them to either of these pathways according to their interests, and both these tracks are well aligned with the industry requirement as well as in collaboration with the industry. So I think that is where Chanakya University's EECS course is updated to the requirements of the industry as well as the demand of the future industries.
Professor Srihari, what advice would you give to students and parents who are choosing an engineering discipline today?
I think that's an important question, Satya. I think this is the most asked question by any parent or a student to me whenever they visit Chanakya. What I have always suggested students is that choose your passion, see where the industries are heading towards, see where there is a good job market, and see where you can apply your skills in real time too, rather than just falling behind a word called placement. Second, as Dr. Kinshuk was mentioning, the World Economic Forum says that the top 3 skills today that the whole world is behind is AI, energy, and automation. So I think electrical engineering and computer science as a branch fulfills all these 3 aspirations. And the most important part of the whole conversation that we are having today here is about building deep domain expertise. So what I feel is, if you draw a T, the horizontal line in the T is AI today. And that vertical line that you draw is the deep domain expertise. And for today's discussion, it is about electrical engineering. So have that domain expertise in electrical engineering, apply AI, and that will be a game changer. And finally, what I feel is, the future belongs to engineers who can apply AI in their areas of expertise. So this is my advice to the parents and students.
Thank you, Professor Srihari. Thank you, Dr. Kingshuk. It was really very insightful session. I'll request ma'am to conclude the discussion.
Yeah. Yeah, I think that gives us all a good idea of the approach taken by School of Engineering, right, in this electrical engineering and computer science program, what each part of it brings to the table, where CS also includes AI, and where we clearly train students on domain specific AI usage, right, in the domain of electrical engineering, and how our curriculum is designed to prepare our students for industry jobs as well as for higher studies if they want to get into research. Okay, so I think we got all the information. Now let's take questions from parents and students. Okay.